Hi everyone, today we'll be reproducing this ML paper introducing setwidth, which is a fine-tuning technique for sentence transformer allowing strong text classification without needing a huge LLM. This is the table we'll be aiming to reproduce. Let's head over to Class.io platform. We'll be using Sonnet 4.6 and an A100 NVIDIA GPU-powered sandbox. With a simple prompt that you see on the screen, we're going to ask our platform to recreate the experiment that produced that, the results, the values in that paper. As you can see, it already identified the paper in the archive, fetched it, and created two research agents that will be doing kind of the background research. First one is doing analysis and search on which data set was used in the paper. It was actually on Hugging Face, so it found it. And then the other one does more research in hyperparameters that the paper used. In the meantime, let's see in our settings, we have some configurations. You can make your dashboard look according to your needs. You can select different LLM models. You can connect your MCP servers and integrate with your GitHub account to, for example, publish this analysis that we're going to do to your account. You can also add your API keys for everything, so bring your key technology is also integrated. So we see one of the agents has finished. This is the one that was searching for our Hugging Face dataset. It did find it. It did some explanatory data analysis even. The other worker is still working. As we can see, it was able to read the paper, identify the exact values that we're asking from it, exact hyperparameters the paper used to reproduce the experiment as cleanly as we can possibly do. Once the two research agents are finished, as we can see here, we are kind of navigating into a different skill called software engineer, which we're moving to this notebook interface, which is the main interface of our Class.io platform. The software engineer skill allows to kind of generate code and interact with the sandbox directly through the LLM in order to reproduce this experiment. We see the steps of our plan on the right. And currently we're in the stage of installing dependencies. You see some errors. This happens because the exact libraries and dependencies used in the paper are kind of 4 years old. And the current libraries we have installed in the sandbox are more newer, but the agent is smart enough to identify it from the paper context and kind of from the error messages and what's happening. So right now we'll also see it kind of fix it itself and see that everything is working okay. I still did not interact with this at all. This is just one prompt. Everything is going itself. Of course, I can interfere at any point. I can change this code, modify, rerun things, ask the agent to do something else. I can also switch to a text-based interaction with the agent, where this is essentially a graph of prompts connected to our kernel states, which is what our neural infrastructure. So we finished the training, and we actually see the results right now on the screen. If you can see that the blue is the paper results and the orange is what we reproduced, which is extremely close, especially in the context of ML papers. We even achieved a slightly better accuracy on the 8-shot parameter, which is, I think, quite impressive. With just one prompt without me interacting with anything, it ran everything end-to-end, was able to fully reproduce this experiment from a pretty comprehensive ML paper.